with APIs. Oh, welcome to the recording. Um, and how we work with data, right, in our domain. So, um, the thing is, when it comes to standardization, OME has historically kind of avoided the term. We began, and if you go back, and I was recently doing this for the OME community meeting, we talked about ourselves as being the glue that takes data off the acquisition systems and gets it either to your visualization or to your processing or to your analysis. We were just trying to build software and tools for you to do your work. And that, the slides got more attractive perhaps over the years, but that was still the base of what we were doing. As we were saying, we will provide this service, open source software to the community, academically funded, to make these things possible. And so OME is not a standardization body historically. It's not even a legal form. Primarily, it's a community that's been getting together. We just had our 19th annual meeting in Dusseldorf, so the first time in Germany this year. Last year it was at Woods Hole. Before that it was in Dundee. Then before that it was in Paris. So it's kind of traveled around a lot. Next year is in Zurich. And if you really want to become a part of the community, that's really the meeting to be. That's where we kind of decide what's the direction we're going. And a lot of what we did talk about this time, though, starts to be this story of standardization. So if you don't know, so the primary products of OME over the years are first Omero, i.e. image data management system. So it lets you access your data remotely. You can install that in your lab or your facility. It is an open source project. You need to have someone who understands IT to run it. There are also companies that will help you run it, and we're working on more funding, especially in the US, to try to build up that capacity. So it's there. I won't talk about it too much since this was a talk about file formats. The other project, which if you don't know, it's a bit surprising, is bioformats. But even if you don't know it, you've probably used it. It is the translation layer de jure and de facto standard for getting data out of proprietary file formats and into a way that most users can work with it. And I'll definitely be talking more about that. But over the years, OME has come up with various file formats. So we'll be talking most about OME-Zarr, which is the current effort. Before that, we built and still support a file format called OME-TIFF. But even before that, in the very early days, so basically turn of the millennium, had a format called OME-XML. And that's where we represent kind of the base model of what an image is. It looks like this. As Allison said, I'm very much on the geeky end of the spectrum. I won't show you any more XML, but I do show it to tell you how important it was to everything we were doing. It was in the first logo of OME, and the logo has changed over the many years. But it's still used in all of our products, this OME XML. And so it is, though, so from a user's point of view, how we talk about images. It is the vocabulary that we share to talk about here, for example, 5-dimensional images. And over the years, we've added specifications for talking about high content screening and other modalities, right? That's what we saw as our role, is coming up with some way for the community to talk about these things in a common way, and then building all the software to make that possible. So this is kind of the dark details of trying to build that type of specification. As we started many, many years ago, and every version we can still read. So if you try to open a 2003 data set, we will apply all the transformations. I'm realizing my hand here is way out of screen. I'll try to do it here. We will apply all the transforms to get you the newest data possible. You can also downgrade. I don't know why you would need to do this. It's much, much harder. We care a lot about losing any information. And so in all these stories I'll tell, what's most critical to us is that you have an accurate representation of what you want to see, but also that you're not losing anything over time, right? And that's kind of a part of the story that comes up over and over. Something else that we realized is, so for example, standardizing the high content screening model of OME took us about 3 years and took us multiple versions of the specification before we could get it done. We were trying to get the community to agree on how they wanted to talk about these things, and we had some very hard conversations. another handful of years down the road, we realized we weren't keeping up with how fast microscopes were developing. New modalities were coming out. We couldn't keep up the rate of updating all this code, updating OMe-Zarr and bioformats, and all the products we had was getting harder and harder. And so what we stopped doing basically in 2016 is try to represent accurately what the companies are producing and instead built in flexible annotations. And that's used quite widely. Basically, any user of OMe-Zarr or bioformats or one of the file formats can represent what they want to represent, but in a non-standardized way. And so people are using that, every day, but it's getting harder and harder for the community to agree on exactly how they're writing things down. And you'll have heard many conversations about, for example, RIMB and how people are writing down RIMB, but they're not doing it in exactly the same way. And basically, it's not in the OME XML specification. So part of this is the explosion of modalities and new technologies and the microscopes that is difficult for us to support. The other part of this is kind of the explosion of file formats. And it's the fact from our point of view, for each one of these, we need to learn what's in the file format and then do the work of getting the pixels out and getting the metadata out to give it to the users. That's where bioformat sits in the overall picture. And it's always kind of a simplification. But we're basically reverse engineering these file formats to figure out where everything is. And I would say we've done a fairly good job of this over the years. We have a repository, most of it is private, of terabytes of data that the community has given us, and we test it every day. So every version of bioformats, we make sure we can test all the files we have going back to the beginning. I know from some companies that that's not something that they do themselves. They only test, let's say the last couple of versions. And so this burden has been put on this academically funded open source project to be the source of truth of reading this data. And at some point we started saying, well, it very much feels like we're on the front line of supporting the users, right? What that looks like on a day-to-day basis is comments come in mostly to ImageSC these days. That something has broken in bioformats. A user has gotten their data from the microscope and can no longer open it. What's going wrong? And they put hashtag bioformats on it, and we dutifully check that every day. So every morning we have a stand up and we review all of those posts. There are cases. Obviously, there are cases where we have made the mistakes, but there are also cases where the microscope has been updated and the file format has changed underneath the user to something that bioformats can no longer read, right? And that's something that's very tricky for us to support because we don't currently have a communication mechanism so that we find out about what's coming in the file formats before it actually reaches the users. And so that's possibly something we need to discuss is how could we do that better? What we do though now is we request that all those files that aren't working are submitted to a Zenodo community with an open license. And we now have a growing public repository of sample files that we can test against and that we show the community this is what we think works. I think we can take this even farther though. So this is the overall list that bioformat supports. It actually looks like that. So it's over 170 file formats now. As you can imagine, that's a lot to maintain. And so we think at this point that it was probably a mistake. Now, so if I could go back 20 years, I'll tell you in a second what I think we should do. But we did start saying publicly that we think it's a mistake. So 2016, we had a blog post, 2018, 2019, these are essentially the OME white papers saying, this is difficult to handle. The growth of the number of file formats was going up, and we are not able to support this. And certainly funders, academic funders, do not want to support the development of bioformats. So we were doing all this to make it possible for the users to do the work. But I think what happened is we got ourselves into essentially a very, very tricky situation. And it's one we need to discuss as a community. So a couple of slides on OMe-Zarr, because this is how important this is to everything we do. Underneath OMe-Zarr, we're translating with bioformats on the fly all of your data to get the pixels onto screen, right? And that happens, I don't want to quite say billions of times a day, but certainly, millions and millions of times. because every time you click, you're going to bioformats and you're retranslating the data. And so usually here I would talk about the various things you can do with Omero. But for any application like this, anyone who's trying to do something interactive with the data, in the backend, a lot of this is happening when you work with these file formats. And if you're using the vendor software that goes with a file format, you have the best possible experience because they're very close to each other. But anytime you're going to work with that data with a different software, you'll be working on it. You'll be dealing with these problems. So with Omero, so the term fair gets talked about a lot. The paper came out in 2016. It's the 10th anniversary. Omero came out 10 years before anyone even started talking about the concept of what's fair, right? And I mentioned that more and more to put it in context, that when we began building these applications, a lot of these conversations weren't happening yet. There weren't many people that we could even talk to about how should we do this. And so we just built an API. When we then took Omero and started to develop the image data resource, so this international repository of data, all backed by Omero, we started to realize the problems that we had kind of created. On the one hand, we were now taking everyone's data, meaning we were the ones who had to do the curation and figure out this large variety of file formats. And on the flip side, people who wanted to consume the data, to reuse this data, which is something that we're trying to enable much more these days, we're having a hard time. And really they just give us tips, just give us something simple. Don't make us understand what's going on. And you can imagine, so these are a couple of slides from Matthew Hartley at the Bioimage Archive. So there are some 14 million images in the IDR. At EBI, they're working towards billions of images, and it's the fastest growing resource data type at EBI. Looking to pass that exabyte mark at some point soon. So what we realized is all of these, especially the repositories, they take the data from the users in the original file formats, they get uploaded. Anyone who's downloading that data struggles with the fact that they have to then figure out how to work with the data. Reuse is actually really, really hard. And so one of our initial drivers was to figure out, okay, can we do something which lets the users access the data without needing to download it and without needing to do any type of conversion or translation? And so that's really what the rest of the story is about. Because if not, we're just placing that burden on the users, on the reusers, right? So what we should have done, so I'm fairly convinced at this point that if I could go back 20, 30 years, 30 years would be too long, I would be too young. We should have started by having an open scalable standard. I now see that comments are coming in. I'll try to look at them in a second. But do feel free to interrupt me if there's something that's important in the chat. I think as a community, we could have focused on this up front. It would have been a lot of work, and it possibly would have been impossible to get it funded, but it now would have prevented many of the problems that we've gotten ourselves into. And one of the reasons Allison got in touch for this talk was the fact that at the 2023 ELMI meeting, the place where we go to dance, it's the European Light Microscopy Initiative meeting. It's coming up very soon in Portugal. I gave a talk. So we had a session on fair data, and with the other speakers in the session, that was Katie Wollstonecroft from Netherlands Bioimaging, Matthew Hartley, who was representing Bioimaging UK, and Guillaume Gay representing France Bioimaging, and me from German Bioimaging. We basically prepared this metro map, which is available in Zenodo and at CC BY. And if you want to share, if it helps you talk to your users about the problems they're having, and I'll be super happy. But what we were realizing and trying to prepare our presentations for that meeting was users are going through multiple hops of taking their data from the instrument. They might have to do some form of manipulation to get the data even into an Omero. And then when they take the data out of the Omero, they have to turn it into something else to get it onto the web. And if they want to share it, the problems just kind of compound. And I know many of the people here, we spend our time, we build training resources, and we try to teach people how to get through this metro map. And I think we could ask the question, could we not simplify things? Could we not, rather than having buses and trains and all kinds of different forms of transportation, can we not have a unified, understandable pathway from A to B for the users. Maybe they have to make an interchange, but still, it shouldn't be as confusing and as scary. And so we were, from the IDR's point of view, we were facing this problem around 2017, and we went on a search for, what would be the solution? What could we use to fix the metro map? We found Zarr. That's what we began experimenting with, certainly back then. For anyone who doesn't know, it's this cloud native format, which essentially means you can take the data and you can put it into commercial clouds or even your own object storage and access it without needing to download the entire terabyte scale files, right? You can access pieces of data. We'll talk a little bit more about that. That means it has a chunk protocol that works in all kinds of different modalities. So you're not necessarily stuck to 2D tiles, small PNGs. You can, let's say if you're doing EM or connectomics, you can have much richer chunks for accessing your data. It's all inherently compressed and other built-in features that you don't necessarily need to care about. And that's kind of the point. It should just do what you need. And we also saw other communities who were adopting, who clearly were buying into this idea of, okay, let's try to have a new way of working with the data. So that led to the formation of this file format, OME-Zarr. And at the end of 2018, we at an Images to Knowledge meeting, but one of the ones in Europe, we looked at the developer community and said, posed the question, are we going to try to do this? Previously, we've tried to get the community to unify behind, for example, OME-HDF5. That doesn't exist, but it was the conversation, should we make that file format? And or OME-TIFF even earlier. And we had never really had a resonance. And I can't tell you if it's because of Zarr, the format itself, or if it's because of the FAIR paper and the community was realizing we needed to do something together. But for whatever reason, I had consensus in 2018. And so I tend to like to work based on consensus. And so that really kicked off the process of trying to come up with a solution. And so as a quick visualization of what this means is, rather than having a single monolithic file, you take your data and you break it up into many pieces, into these chunks. That's basically it, really. You do it in a smart way so that it works really well and it's very efficient. The downside is you do have a folder of stuff. But to be honest, many of us have a folder of stuff anyway because we have a TIFF stack, right? And so it's not a far reach for a lot of the community. And since you've already broken things up into multiple files, you can take this header information that might be at the top of the HDF5 and you can put it in at least an easier to read file, say in JSON. And you've now got this format that's fairly web compatible. So we have these URLs and you can take the same URL and you can give it, for example, here, all the applications on the right, NeuroGlance or Mobi or WebGnosis. And it all just opens in exactly the same way. And from the user's point of view, they haven't needed to do anything. They haven't needed to download. They haven't needed to transform. They don't have to use bioformats. Quote unquote, it should just work. And so while doing that, we kind of realize, well, maybe this is becoming our standard access protocol in general. So we were doing it because we definitely needed a solution, but possibly it's something that would fix kind of this decade-long problem that we've been dealing with. And then from our point of view, and maybe from others in the community, what we want to do is then go back to Omero, because we said it was pre-FAIR, and add in this protocol to it. It becomes the common way of accessing even the older applications. And then we have something consistent across the board. We have this green metro line. That's a lot of words. At the end of the day, it comes down to really agreeing with at least the other developers in the community on how we're going to write things down. We realized, so around this period of time, 2017, 2018, that people were already solving this problem. It hurt, ergo, we're going to fix it, right? But they were doing it in slightly different ways. So we have these imaging pyramids. You take the image and you downsample it a couple of times. It makes interactive visualization much faster. But people were either adding a prefix or doing the numbering of the levels of the pyramid slightly differently. And therefore, we needed something. And so this conversation was basically about getting this little block of metadata. You don't have to care about what's in it, but we needed that specification. We needed to agree on how we're going to do this. if we're going to have a standard, right? And so that's what became the NGFF specification. It became the basis for this file format OME-Zarr. Um, Obviously, it's gotten more complex, more sophisticated since. So this is a figure from the 2023 paper where you're representing the entire high content screening in the same layout and shows you the different levels of complexity in that. So where you're either accessing a whole terabyte of data in a fairly fast to load view, or down to the individual chunks, which are just a megabyte. But what we were trying to do with that paper is get as much of the community, the developer community, together as possible. So it was 69 authors and some 33 institutions, I think, basically making the public statement, we're going to try to do this. So from the academic side, saying, we really think we need some kind of standardized protocol for doing this work together. That's grown. This is now the list. I think I made this for my slides at the 2025 ELMI, but I got tired of updating a slide deck. And so it's now a repository. And if you think you've contributed to the OME-Zarr community, you can add yourself by opening a PR, and more people are obviously welcome. I think so it's a bit of a snowball effect. The more people that are involved, the faster things will go, the more we will be able to provide tools to the community and be this glue. So, that's kind of the end of the glue story, because things started to change slightly. So, end of last year, we started talking about what would OME-Zarr 1.0 look like? How do we get to a format that we think is stable and we really want to tell everyone to use? And if you don't know, there's an annual NGFF hackathon that takes place in Zurich. This past year, though, there was an international symposium. And so there's another slide deck from the symposium where I start to talk about this road to OME-Zarr. And I just gave the name to the organizers as the title, and needed to figure out what was I actually going to talk about this story. And so it started off bioformats, this thing I've been telling you about that's so critical was like laying the tarmac. It's the basis for everything we do. You have to do that, otherwise you can't even get started, right? There are roadblocks and things that you just have to fix. You've heard me talk about those. And what I realized then when I was talking about the IDR is, because the data was so large, they were telling us that we had to move our data into the cloud. And that's when my metaphor broke down. It's roads don't get to the clouds. You need something else. And so I think actually what we're dealing with is an inflection point here. So if I were to make a bet at this point, is all this work we've done for the past 20 years is really building a runway. And I think if we can get to the point where we're standardizing how we're communicating with each other with data, we can take off. Like we can have this inflection point where we really start doing something that we've never been able to do before as a community. And so that's what I was trying to get across at the symposium. And in a very kind of, going back to the geeky end of the spectrum, there's something in software development called the hype cycle. It probably applies to all forms of technology. In the hype cycle, you start off with a new technology, and initially you have inflated expectations. And I was certainly hearing even years ago from meetings where people were saying, OME-Zarr is going to solve everything. I was like, oh, wow, okay. We're going to get ourselves into trouble here. And so that's probably where we are now, is this trough of disillusionment, when it doesn't solve everything for everyone and people are therefore mad at you for not having solved things you didn't promise to solve. But that's okay, that happens. And the thing is, you then eventually want to get to this point where you just have kind of this solid underlying technology that you can depend on. And I'm sure we've all seen other technologies get to that level, and I think we want to do it here as well. Excuse me, I have to cough. So there's a mapping, though, which is something called the adoption curve. And so getting ready for the symposium, I realized the people who had adopted OME-Zarr early were those who had the roadblocks, right? There are people who simply have problems that aren't fixable with pre-OME-Zarr technology, and either they wanted to find something from us, from the community, or they were going to have to build it themselves. And so what we're doing now is really building it together, right? But there's this whole other population of people who are out there that we need to pick up. and somehow we have to get over this chasm. Yeah, I think that'll happen when we take off. But that what it's going to take to get there is a standard, is really saying, okay, every time you open something in Fiji, every time you open something anywhere, anytime you drag and drop, you're using the same thing. You want to get basically to the level of usability as a PDF. We're not there yet, but that's what we're going to work towards. Kind of in a different representation. So what we've been adding, so kind of from the OME point of view, what we've been trying to do to get people to this point is basically add on other community, add on more use cases to what we're supporting. There was the initial development that was just for the developers. Then we scaled up for big data purposes. I think we're in a period of stabilizing right now. And so I guess give us the rest of this year. Let us see how far we get with the stabilization. But what we want to do really is start getting the community on board. And what we will need people to do is then tell their vendors, when you buy a microscope, when we get to this point of 1.0, we need to all be telling the same story. At that 2023 ELMI meeting where Allison heard me give one of these talks, she asked me after the session, do I need to understand any of what you just said? Like, do I have to care about that? And to a large degree, no, or I would like you to not need to care about it. But the fact is, if we're going to have a standard, we need to all say with a single voice that we want a standard that we're working on, right? And you can let the developers deal with the details, but we need to realize that it's going to change how we work and hopefully enable new science. So from our point of view, we have a roadmap. I announced that. It's online on Zenodo, as is everything I do, I think. We work in these RFCs. RFCs are requests for comments, and it's basically a kind of a large public way for us to tell the community what we're doing and take their feedback. And so there are several RFCs that are open and ready for people to comment on now, people and or organizations. There are a couple that are being worked on right now, and they'll be opened up soon, and then several more that are coming. And this process will continue. Even when we get to 1.0, we'll still want RFCs. Anytime the community needs a new modality or needs a new technology, they should let us know through these mechanisms. And everyone, really everyone, is welcome to get involved in that process. Something I couldn't announce when I was showing this, but we built this roadmap with something in mind, which is that we recently got support from BioHub, formerly CZI, basically to found a new cooperative, so a workers-owned cooperative called Image Co-op, to help drive this development, right? It's built of a handful of research software engineers with various experiences across the open source community. So that's OME, Napari, Scikit, Image, Zarr, CatMade, spatial data, et cetera, et cetera. Together with a group of contractors, what our plan is to shepherd all of these RFCs. So one of the things that OME-Zarr has suffered under is that basically only my position was funded to make all of this happen. So I was funded to drive the work, but I basically had to beg the community, beg open source developers to help. And they did an amazing job. It's been wonderful. All kudos to this list of 100 different people who have done the work. But it's hard to commit to a timeline if you don't have the capacity to work on it. And so what this is about is having that capacity, having the developers to get us to a stable point that has an extension mechanism, basically allows the community to build on top of something. It won't have every feature everyone needs from day one. So I don't want to kick off yet another hype cycle, but I think we'll be in a much better place. And there are blog posts that you can read about the state of that. And so the other contractors who are on board are those who have been involved in the development of OME-Zarr from the early days. As I said, we'll be pushing the RFCs and running hackathons. So if you have developer teams who would like to get involved, please let us know. The other thing that we're actually the first task of the co-op is to assess the needs of the community. So does that roadmap of RFCs represent all the features that are needed? And so there's an email here. I'll put it in the chat after I'm done talking. get in touch. If you don't feel like your needs have been heard so far, now's really the time to make that happen, right? Okay, this is the timeline. Obviously very rough, but the funding is for 12 months to basically get to a first stable release of that 1.0. And we're going to make that happen to the best of our ability. That'll be 1.0 alpha. And at that point, at the latest, I will be coming around to individual communities, and I'll probably get in touch with someone at BINA, but also to the various vendor representatives and say, okay, are we doing this or are we not doing this, right? Is anything missing? What have we forgotten? It'll be interesting. Let me just leave it there. I'm running a little bit short on time, and so I'll maybe just show these slides. It's one last slide deck that I showed to Allison about what she wanted to see, and she was like, "Yes, of course." So she wanted everything. The developers at Zeiss, or some of the developers at Zeiss, invited me to give an internal talk on what OME-Zarr is. So I've talked about that a little bit, but also what it would mean for the vendors, right? You know, what's the benefits to them of doing this? And those slides, the whole slide deck's up there. I can't go through all of it. So a piece of this is that in 2010, in the Metadata Matters paper, which is the foundational bioformats reference, it's the most cited OME paper. We said, so here are tips for how we think we need the community to work with vendor file formats. And point 6 was we need data exported to an open metadata specification. And so part of that is just exporting to OME XML. So we can do it to some extent. But one of the things we've realized is there's data that's being lost. There's uninterpretable metadata that bioformats doesn't understand in the file formats. And therefore, users don't feel comfortable converting. They have to always keep the original file because they can't be guaranteed that they've gotten all the metadata out of it. I'm pretty sure we have all the pixel data, but not all the metadata. And so if we're ever going to have a standard, we need to address this. So this is one of the major things that's still coming. And I was kind of talking through this. And what I don't want to do in all of this is make it a pairwise comparison. You know, what's this file format against this file format, and what's the value and what's the cost? We can do it if necessary. But the real thing to get to is what's the value for everyone of having a standard, right? And I'm not going to, I'll go ahead and just click through the whole slide because I don't think we have time. I think we actually want to do more conversation. But a lot of this, so everything with a star on it, is something that impacts the users. You know, so obviously the companies care a lot, and rightfully so, about the quality of the user impact, and therefore they own the file format and they can develop it exactly at the velocity they want to, and they have the quality they want. They do have costs. They have to develop all that, and there's this whole problem of supporting bioformats. But I think as soon as you start to think beyond one user sitting on one instrument, you start to see this problem of the metro map and the fact that the users are actually suffering, and it's more than one users, and you want your data to be used for a long period of time. And so you've actually externalized all this cost, and people are paying the cost of transforming it over and over for forever if your data is good, right? And so I think we have to kind of rephrase this conversation and look at it again. Our role here will be to offer a solution, and I guess especially for the users in the room, it's your job to kind of demand that solution if that's what you want. Okay, one last kind of image. I love this a lot. It comes from the Founding Guide project from Maria Mirza. I think it kind of represents a lot of what I've said in a single picture. Most users have a visceral feeling for the pain of having too many plugs and not the right plug, and trying to figure out what to plug into what where. USB-C has its problems, but I think it's a motto I can get behind. Keeping in mind, though, it took EU law to force it to become a standard, at least in Europe. I don't know if we can do that or need to do that. Maybe we can we can solve this from the bottom up. Okay, the quote to that: creating metadata formats and data formats is actually quite easy for a developer. Right? You can do it in a day, right? The really hard part is doing this together. And so I think that's where we need to invest our time and our effort, and figure out if we can't make this work. And so with that, I commit OME to doing this. Like, we will keep driving this RFC process, and we'll keep getting investment in OME-Zarr, and we will get to a stable version. And maybe from your side, engage with that process to the extent that you can. Express your needs either to us or to your vendors, especially to the vendors. Endorse the version if you can. If you can't, let us know. That's fine. It's okay to say it's not possible. And maybe for everyone, see how you can get involved with an OME in general. Yeah, lots of fun things are happening. So with that, I'll say thanks. Shout out to the funders. There's the link to the Zenodo again. And yeah, I'll be quiet for a bit.